So, good morning, ladies and gentlemen. Many thanks for joining us for the first URBIOFIN workshop. We will start in 1 minute. And first of all, we would like to check the sound. So please, can you write in the chat if you hear as well? So if anybody can write a little bit to check that you are all.
You can use the question function. During the webinar, you will have the opportunity to ask questions while using the question function, because due to the large number of participants, all participants are on mute during the webinar, but you have a chance to make comments and ask questions by using the question function. And so to quickly test that function, you can tell us whether you can hear us. Okay, I see many answers. You can hear us perfectly, so that's great.
Okay. Yeah, as you may have seen in the agenda, we have 2 blocks, each one followed by a QA time. So the first block deals with regulations, municipal waste management and curing initiatives, and the roundtable. And the second block will deal with the URBIOFIN project. So now I would like to introduce Mrs. Caterina Goy. She's Innovation Manager at IMECAL with more than 20 years of experience in process development at lab and industrial scale. And she's a project management professional from the PMI Institute and URBIOFIN project coordinator. So please, Caterina.
Thank you, Sarah. First of all, I would like to thank, in the name of the URBIOFIN Consortium, the huge assistance to this online event. During these 2 hours, as Sarah said, we would like to share with all you a new vision of the municipal solid waste management in Europe, new alternatives, new possibilities that are being developing in the field in the field of the municipal solid waste management, and of course the barriers that these new developments have to be applied in the municipal solid waste management. And now I'm going to start with my presentation. Okay, have a little bit of delay when I press. Let me 1 moment.
Yes, now we have the next slide.
Okay, thank you. Well, as I say, we are going to speak about waste. Nice picture, but this picture is what we create every day. Then in the world, we are producing around 1.5 tons of municipal solid waste. And we're speaking about billions, okay? And it's expected to double this quantity in the next 7 years. Then we have a huge quantity of waste, and we have a problem or an opportunity. It depends about how we say the issue. I can't pass to the next slide. Anne-Marie, maybe can you next one? Okay. In Europe, we generated one before, please. Okay. In Europe, we generate around 250 million of tons of municipal solid waste. Okay. The state is the 2 years ago. Then, depending on the country, we have different treatments. The medium of Europe is that we recycle around 30%, landfilling 23%, 28% of municipal solid waste is incinerated, and the composting and anaerobic digestion is done by the 15% of the municipal solid waste. Next slide, please. then we have a problem, but as I said before, an opportunity, because from these 250 million of tons of municipal solid waste, 100 of tons are urban bio-waste that we generated every year in Europe. And only 1/3 of this municipal solid waste was collected separately and composted and incinerated. Then we have a lot of bio-waste that in the next years are going to improve because the waste collection framework, and we have the opportunity to take this waste and transform it in valuable bioproducts. We have legislative drivers that aim to do it. The revised legislative framework of waste aims to separate the bio-waste in 2 years, in 3 years. Then all the countries in Europe are implementing this directive. We have to reduce the landfilling to 10% and increase the recycling. We have the European Action Plan of European Circular Economy that see that the waste is a resource, and the European Bioeconomy Strategy, and of course the Renewable Energy Directive that aims to displace the fossil fuels for green energy fossil fuels. Next slide, please. Then, as I said, we have the waste, the opportunity, and we have the legislative framework. Then the idea is just to take this opportunity to introduce in Europe a new ways to treat the municipal solid. Sorry, go to the forward with the slide before, please. No, too big. One more, please. No advance, go back, please, this one, okay. Then, as I said, we have the bio-waste, and we have the legal framework just to change the municipal solid waste vision and the processes that we implement in the waste management. We can produce more bioproducts with bioenergy from the urban waste, increasing the value of this resource. Please, the next slide. During the last 12 years, no, one before, sorry, because I can't have the control of the presentation. One before, please. Okay. During the last years, Imecal, my company, is working in developing. Can you move one slide before, please? It's one. This one, okay, fantastic. Thank you so much. Then Imecal is working in different developments focused in biorefineries and bioproducts. Now we are coordinating URBIOFIN project. This is the theme of today. We are going to speak about this interesting demo project. We are working in Percal project too. We are developing different building blocks. Waste to Bio project, that is an European project that is more focused in bioenergy, and Waste to A project that has 6 pilots from different kind of wastes in order to give value to these wastes. I have to say that URBIOFIN and Percal project are granted by the BBI Joint Undertaking, Bio-Based Industries, and the Horizon 2020. Please, next slide. And why we propose a biorefinery? No, one before, please. No, one. Move one. Okay, no. Next one. No, one more. Can you move one slide, please? No, one before. Okay, we can find the slide. Then why we propose a biorefinery concept? Well, because it's a versatile way just to propose a biorefinery. It's a modular design that can be implemented in the current municipal solid waste treatment plants. The idea is not to change the model; it's just to implement the model with no modules that can give more value and replace part of the fossil fuels with these green bioproducts and green bioenergy. And now I give the floor to Andrea Gorici. Andrea Gorici is a project officer for the circular economy and bio-based systems of the DG RTD of the European Commission. He's managing the files urban circular bioeconomy and circular cities and regional initiative. Andrea, thank you for assisting to the conference, and I give you the floor.
Thank you, Caterina. Can you hear me?
Yeah.
Perfect. So thank you for the invitation. And yeah, indeed, maybe we'll take the idea here just to explain a little bit the policy background from also where URBIOFIN is coming from. And basically, I divided the presentation in two chapters, if you want. Chapter 1 is really the file that we started in 2015, where URBIOFIN is coming from, and is really focusing on the circularity of bioresources at the territorial level. So if you want one part of the circular economy, the other file, the new one that we started basically last year, is represented, if you want, by this new initiative, which started from the GRTD, but also in cooperation with other DGs, of course, in the Commission, and it's called Circular Cities and Regions Initiative. So let's maybe start with the next slide. And I start with chapter 1, if you want. Again, territorial focus, the circularity of bioresources. Next slide, please. Yeah, so basically we started, as I said, in more or less 2015 to say, okay, there is a value chain or several value chains which are quite interesting from a bio-based and circular point of view. The aim is really to valorize, to extract more from bioresources at the local level, especially if these bioresources are not conventional resources, are normally bio-waste, wastewater sludge, so something that we normally throw away or we valorize just a little bit, we compost, biogas, and that's it. So here the idea is really to put technology to really extract more in a sustainable way, more products, more value from these bioresources that we have at the local level. And we really started to identify what are the most efficient, the most interesting waste management scheme for biowaste and wastewater in Europe. The same we did it for technology, value chains, and we really try to understand the technical, the regulatory, the financial aspects of this value chain and management schemes. And we identify the main, let's say, challenges, the main potential of this value chain. And we ask, okay, how can we do from the European Commission, especially from the GRTD, really to support this interesting policy area? Next slide. We started with the purely technological level. So we really try to see how the technology able to extract more from these bioresources, how to help them to achieve the commercial level, to achieve a technology readiness level higher than what they are. The TRL is, as you might know, is a way to identify how technology is at the laboratory level still or at the commercial level. And we started with a couple of research innovation actions, so pilot actions. The TRL is quite relatively low. The projects are Resurbis and Percal, that Caterina already mentioned. But then we immediately consider also the level up, if you want. So basically, we supported specific calls. From this call, we have Embraced and URBIOFIN. These are demos, meaning the TRL is higher, it is close to the market, but still it is mainly purely the technological aspect of the story. Then next slide. As a second step, we really try to include this technology in the urban metabolism. So try to see a city as an organism with bioresources and flows, etc., and how to valorize these local resources to produce bio-based products, which are important for the economy, important for the environment. Also, some of them are really important also, if you want, from a geopolitical point of view. If I extract phosphorus, which is a critical raw material for Europe, normally imported from outside, then is a good point also for the economy and for also producing something at the local level instead of considering a pure import policy. We start immediately with innovation action, because in the demos you really understand whether the value chain, whether the technology has the potential to go ahead or not, even though the investments are significant and sometimes the profits are limited. But it's really the technological level we really understand. So we supported the launch of 3 projects: Calibur, Biowaste, Waste Up, already mentioned by Caterina. And now we are really try to have a flagship, meaning a level up. We are even closer to the commercial level. There is still a BBIJU call for proposal open until the beginning of September, so the time is quite short. But for those interested in, can be a quite interesting, call for really pushing again the technology in a systemic way, in a territorial way, in a circular way, really close to the market. Next slide. The other level of, let's say, research innovation action is this project development system. Was a call that is really focusing on really creating the technical, financial, juridical expertise in a city with circular ambition for the bioresources, and help to translate this idea, this strategy to valorize local resources, local bioresources, into real investment. And that's normally what the project development assistant helps you for. And that's, in my opinion, is a quite interesting call, now under evaluation still. But the idea is really to have a territory with a circular idea for bioresources and helping it to move from the idea to concrete investment for the implementation, which is crucial. Next slide. Of course, the technology, the systemic solution is not only the main focus that we have if we really want, that we need to have if we really want to be helpful for this policy development. We also focus on the regulation. So here is this survey report, the hyperlink, is really a report, I think is one of the first one, really to understand the regulatory obstacle and regulatory drivers at the EU level, really to help the development of this value chain. So what are the EU legislation containing aspects that helps and some aspects that don't help for the TRL upgrade and for development of this value chain. So regulation is fundamental. We analyze it, and this study is, in my opinion, a good starting point to map a little bit elements that helps, elements that don't really help the development of this value chain. Next slide. And of course, we focus also on the financial aspects, and under one EU initiative developed by DG Regio is the EU Urban Agenda. There was a partnership on circular economy with the participation of industry, cities, region, member states, part of the Commission, and they produced the Circular City Funding Guide, which is, in my opinion, a quite interesting instrument. You can access it for free, it's online, and is really taking the point of view of a project promoter of a city that wants to be circular, potentially also on bioresources, and see a little bit concrete example of case studies, concrete example, financial scheme, they really help you to go ahead with the implementation of the circular policy, also on circular bioeconomy. Next slide. That's quickly the chapter number 2. So now from last year, the unit of bio-based system and the unit of circular economy merged into one unit. So now the territorial and circular bioeconomy focus was enhanced to still a territorial, but a circular economy focus. So basically including not only bioresources. And that's a little bit the focus of this new initiative, which is including the Circular Economy Action Plan, the new one at the EU level. And it's called Circular Cities and Regions. And we are still working on it, on the setting up, but what is very clear here is the focus is really on the circular territorial solution, really to try to push, to support the implementation of the circular economy, including circular bioeconomy at the local level. Next slide. The first element that you can see from outside is a specific draft topic, really on territorial circular economy, is part of the European Green Deal call, and it's called the demonstration of systemic solution for the territorial deployment of the circular economy. Now, it is a draft, should be finalized by and published by September, but is available online. There's the hyperlink down there. And you can see really that the focus is really on the demonstration of projects, innovative basically innovative value chains at the local level. And when I talk about circular economy, of course, the bioeconomy is part of it. And the very last slide, the next one, gives you a little bit the timeline for this potential call. Now, there was until the 3rd of June, an online feedback, but then especially now by mid-September, let's say that the call should be finalized and be available for application. And then you see a little bit the timeline for the application and the follow-up of the call. And I think I stop here. And thank you again.
Okay. Andrea, thank you so much to share with us your knowledge and all the links of information regarding the bio refinery project. And thank you for your vision. I know that you are very busy, and I really appreciate your intervention today in this workshop. Thank you so much, Andrea.
Thank you very much to you. Bye-bye.
Bye-bye. Okay, and now we are going to give the floor to Telmo Machado. We have a problem with in the agenda because due personal problems, Vanya Veras will not be connected to the webinar. Then we give the floor to Telmo Machado. Sorry, it's Telmo Machado. It's a consultant of Resilience Development and Innovation Unit at DIPOR, Portugal, with a track recorded experience in application of biotechnological solutions for waste treatment and valorization via microbiological and bacterial waste. Telmo is going to give us a vision about the DIPOR strategy for bio-waste and the Porto region case. Telmo, thank you so much.
Thank you, Caterina. Good morning to everyone. I will try to explain you. I'm sorry for the lack of light in my room, but it's difficult because in Portugal it's not a sunny day today. But I will try to enlighten you with information about the Porto region, the Porto city. So I don't know if I can control. No, I can't. So thank you. So LIPOR is the waste manager of Greater Porto, but it's not just a company. We are an association of municipalities. We are 8 municipalities that serve almost 1 million inhabitants. And this 1 million inhabitants produce every day around 5,000 tons. Is 5,000 tons of waste every year. And so LIPOR and the municipalities have to deal every day with this amount of waste. And how can we do it? Next slide, please. So we have the effort divided between the municipalities and LIPOR. The municipalities do all the collection, or almost all the collection of waste in the Porto region, and they bring us, we have two different sites in LIPOR. We have one site in Gondomar, it's one of the municipalities, where we bring, where the municipalities bring all the recyclables, the bio-waste, cardboard, the plastics, and also the bulky plastic. But when we are talking about the mixed waste, all the material go to another municipality, another site of LIPOR, which is our waste to energy plant, where we incinerate the material that can be recycled, and we produce energy that can feed about 150,000 homes in the Porto region. So we have to deal with this amount of waste, and we believe and we know that in the material that goes to the mixed waste, the waste to energy plants, we have a lot of bio waste. So we want to catch all that material, and we designed a strategy. Next slide, please. We designed a strategy where we looked at the material that we had in 2018, for example. This is just for the bio waste, not for all the waste, but just for the bio waste. And we realized that 67% of material that is going to the waste to energy plant is bio waste. So we have also other ways of managing the bio waste. We have a centralized bio waste plant, a composting plant. We have several projects on composting, and we also bet on prevention, but we still have a lot of material going to the waste to energy plant. And because all you know, we will have a mandatory separate collection for bio-waste in 2023. So we have to think about how we can manage to deal with all this waste and try to retrieve it from the waste to energy plant, from that plant that is consuming bio-waste just for producing energy. We believe that bio-waste can do a lot more. And so we designed this vision for 2023, where the centralized treatment will treat about 46% of all the bio-waste that is being produced in the end municipalities. But we also want to focus on the reduction and the reuse of material. We have here, I'm sorry, we have separated the 10% and the 46%, but I will explain how we can manage this on the next slide. And so we believe that all the effort at this time is on the side of LIPOR and the municipalities, but we want to distribute this effort. We want to imbalance the effort of waste management. Could you please put on the next slide? Thank you. So we thought applying the Lancic ladder about reduction and reuse, and just then we can do the incineration. We believe that we have to balance this effort, and so if the citizens will help us on the on-source reduction and reuse, we can deal with the bulky material on the centralized and the incineration. This will, as I said, imbalance this effort, so we can do more with the projects that we have. And I will present you on the next slide. Could you please? Thank you. We believe that the citizen could help us do a lot of this work on the on-source reduction and reuse. Of course, this will have more effort for the citizens and less effort, no effort for LIPOR, but less effort for LIPOR and the municipalities. But we will engage the citizens in the reduction and the reuse of bio-waste. This is an example with the projects that we have on prevention of food waste with restaurants. We work with restaurants to reduce the amount of food waste they produce. We also provide the restaurants with a doggy bag skin, which is called Embrulha. We try to make the doggy bag a little bit sexier than it is. And so we offer, as you can see on the image on the right, the paper bag and the doggy case, where you can use the leftovers that you have on the meal and take it home, so you can eat on the next day. This is a part of the prevention of food waste, but it will also have another way of reducing the food waste. We are working with several entities to implement urban food production in small urban farms, where you can have your small plot of 25 square meters and you can produce your own food and also compost your leftovers that you bring from home, and of course of the plots itself. We also have more than 14,000 compost bins that were offered by League Board to everyone that has a garden. At my home, I don't have a garden, but I have a small terrace where I can do worm composting. This is another way of reducing the amount of bio-waste that we deliver to the municipalities. And so this is our way of doing the prevention of production of food waste and bio-waste, and also a way of dealing with the waste locally with the local composting. Next slide, please. When we are talking about the centralized treatment, as I mentioned, we have a composting facility that works with the food waste that is collected from restaurants, from the households also, and from big producers, the industrial food managers. We collect that material from the municipalities, and some of the entities also deliver the material to us. We pick up that food waste and we mixed with a garden waste that comes also from gardeners, also from our own homes. We can call the municipality and they will collect that material and deliver it to our composting plant to produce a compost that is of great quality. We also have the separate collection for materials that come from cemeteries. Here in Portugal, we love to put flowers on our relative graves, and so we also collect that material because it's good material. It's almost like garden waste, and we can use it on the compost. Next slide, please. And so when we thought about doing a composting facility, we didn't thought about it as a waste management facility. We thought of it about doing a product. It was a factory to build a product, to produce a product. And this changed our way of looking at bio-waste, because if you wanted to do the best compost possible, you have to get the best bio-waste possible. And that is only feasible if you have a separate collection. And that's what we did. We implemented the separate collection in the 8 municipalities for big producers. We teach the people from the restaurants how to separate the waste. We explain to them, we show them the compost, so they could understand that what they are doing when they are separating the materials, they are helping us produce this quality compost. And this compost is it has so much quality that it can be certified for organic farming. So if you are an organic farmer, you can use this compost to produce your own products. Please, could you, thank you. But we are not only working with a compost, we are also looking at other materials that could appear in the compost. One of those materials are the so-called biodegradable or compostable packaging, which we have tested, and we seem to have a lot of problems with the compostability of those materials. So we do this testing to provide our clients, our citizens, the information on what they are buying, if they are buying really compostable materials or not. We are also working with a Portuguese company, which is called Spawn Foam, that is producing, this one is really compostable material, and we are helping them with development advisory so they can really deliver to the market a compostable package. Other products that we are building with bio-waste are the microalgae. we are building up new materials and new products from microalgae with the help of a national project that is developing this new products. I can talk much about it, but we are ongoing, and we believe that we will deliver some different and interesting products from microalgae. Next slide, please. But because we can't do everything with a reduction of bio-waste, we can do everything with just one composting facility. We are now implementing and designing a new anaerobic digestion plant, so we can deal with the material that is coming until 2023, all the bio-waste that we have to deal with. And we believe that with anaerobic digestion, we can also produce quality products if we can manage them in the same way as we did with a composting facility. But still, when you look at AD, when you look at the anaerobic digestion, there's still a lot of products that don't have the quality that we want to. So we believe that the connection between a biorefinery and anaerobic digestion is the solution for the future. And we believe we can do a lot of products, a lot of different products, and many of you will hear about it on the next part of this webinar. We can build up biofuels, bioplastics, just with the materials that come from anaerobic digestion and bio-waste, of course. We are dealing with this material with the idea of a biorefinery with a partner that is PLC3. It's a center for technology and innovation here in Portugal. And we have a collaborative lab for circular economy, where we are dealing with this kind of strategies or ideas that we have for the future of bio-waste. Next slide, please. And so, as you can see, the LIPOR has already been involved in circular economy before it's called circular economy. Since 1982, we are doing circular economy, but we are already also in the bio-based economy. And these two notions have to work together. And as you can see in this image, if we continue the cycle of the circular economy, and if we continue the cycle of bio-based economy, we'll end up with an infinity symbol. And that's what we want to do. We want to reuse the materials every day in different cycles, but till infinity, so that the bio-waste of today could be a great product tomorrow. So that's what we are working on, trying to do the best products with the best waste. So if you have any questions, please. Thank you very much.
Thank you so much, Telmo. Just to share with us the LIPOR experience and vision for the how to move on to the bio-based and circular economy. I think that congratulations for your work in LIPOR. I think that is aligned with our vision, just to move to a biorefinery. And congratulations and thank you for sharing your experience with us. Now we have a round table just with the participants of the first part of the workshop. Banja, as I said, is not going to participate in this roundtable because he had personal problems. But I would like to introduce you. Telmo, can you open the camera, please? I would like to introduce you. Jose Maria Gomez Palacios is a URBIOFIN member and is a CEO in Biomasa Peninsular, with around 30 years of experience in waste management. He's member of the European Commission working groups related with policies in sludge, bio-waste and soils. And I think that he can give us a vision regarding the legislations and the barriers of these project implementations. Telmo, can you please open the camera to be in the round table too, please? Okay. I don't know if he can.
I'm trying to.
I'm trying
to, but it's not working. Oh, okay.
Okay. And now we can see you. Okay. This roundtable, as I said, we need to have in account the European Union with the Waste from Framework Directive and the Circular Economy Action Plan is aiming to introduce the biorefinery concept in the municipal solid waste management model. Then I would like to know if you're from your point of view, and taking in account that not all the municipal solid waste treatment models will be applied to all municipal solid waste plants, because we have big municipal solid waste plants and small municipal solid waste treatment plants. I would like to know from your point of view, what are the main challenges, technical, regulatory, logistical, for the valorization of the organic fraction of municipal solid waste in bioproducts and bioenergy. Telmo, you want to start with this, with your answer, and later Jose Maria?
Yes, it's so much questions in just one question, but I will try to answer all of it. I think there's a lot of challenges in the dealing with bio-waste, because it starts with 3 letters, B-I-O. So every time you deal with bio something, it's difficult to work with. It's not metal, it's not plastic. So it's a living thing, and I believe we forgot that we forgot to deal with bio-waste as a living thing. And if we look at it as a living thing, we will start to manage it as a living thing, as we do with our food, as we do with our animals. We have to look at bio-waste because they have life in it. They have microorganisms that are living in it, that can grow with it, and so it's completely different from plastic. We can't just be I'm sorry for all the engineers, but you can just be an engineer and look at bio-waste as the way as we look at other materials. So you have a lot of challenges. The financing of this kind of projects, it's difficult. It's not impossible, but it's difficult to try and convince all the politics that we are going in the right direction. But I believe it's possible, because when you have a European Commission that will support this kind of projects, if we build the project in the right way, we can surely do it and have great results. I don't know if I answer everything that you asked.
Yes, I think that you have a clear vision. Thank you, Telmo. And Jose Maria, please.
Good morning, and thank you for the invitation. My vision is that now we have a good part of the schemes for developing the bio-waste, the circular bio-waste. That is the legislation. The legislation part, I think there is a big progress, and of course, as a summary, I would say legislation. We have the waste circular economy package and new waste directive 2018. So it's the base of the thing, and the targets are very strong and very. We have to comply very fast in terms of developing municipal policies and municipal measures, and we have a lot of derivatives from this directive. Of course, we have the end of waste criteria for compost and digestate, which is also a base for many things. We have the fertilizer product regulation from 2019, so we can now make CE fertilizers with the bio-waste. And we have also a new regulation for the plastics. I'm not so familiar with it. I think it's 2018. So it's the prohibition of the oxo-degradable plastics. I don't know if maybe Telmo can tell something about that. So I think in general legislation we have a lot of things, and I would say that the limitations comes from two sides. One side is the practice. So it's not so easy to put in practice there is a lot of creativity and the projects and the ideas and technologies, but still is a little bit of development is going to be done by technology and by projects and by different initiatives. So it's no the legislation it is, but the way to reach these objectives is not so easy. And the third part of the answer for me is the barriers, of course. So there is legislation, but there is a problem with the standards, with the technical standards that are developing slowly than the reality. And we have also the citizens collaboration, the perception, the price of the bioproducts, and so I think this is, I don't know if I answer, but this is my vision of the situation and the good things and the limitations.
Mm-hmm. Well, I understood that from your questions that have a technology to do it, have good and less good and more viable and less viable technology to obtain more value from the waste, the bio-waste products, but have a legal barriers just to introduce these bioproducts in the market, as Jose Maria said, due to the end of waste criteria. In the new circular economy action plan, have measures as Andrea said. Because they in the last years they work extensively to know which are the legislation who can bring the bioproducts to the market. Then have actions just for the end of waste criteria for the next year. Then I think that are good news just for the bioproducts. And coming from waste to go and to the market. Just to share the vision for the Paris that as Jose Maria say are moving slowly, but are moving. Then I think that when the projects will be well developed and of course economically viable, because it's important the viability of the project. The legislation will be ready just to move on to the market. Okay. I have another question for both of you. Then I would like to that explain the main societal benefits that the circular processing and conversion of municipal solid waste based on biorefineries can deliver compared with the municipal solid waste management models. I think that Telmo shows the answers in the presentation. No, Telmo?
Yes, I really wanted to go a little bit backwards, because if we are talking about what can the bio-waste do to the citizens, and how can waste managers deal with the retribution of the effort from the citizens, it's really important to think about how this mandatory collection system will work in Portugal, because when we receive this information, we smile with joy, because we thought, okay, now we can do a greater bet on the composting facilities, on the small composting facilities, on the local composting and the local treatment. But then as the Portuguese regulatory agency look at legislation, the decision wasn't the one that we expected. So we believe that we could bet more on the local composting, on the local treatment, but then our regulatory agency said, no, you have to do all the collection in all the places of the Porto region. This does not make sense, because when you have a lot of material in a place, yes, it makes sense to do composting, to do anaerobic digestion. But when you live outside the cities on a rural zone, it's not the best way to try and collect that material and bring it to a centralized system. You have to deal with it locally. But thinking about how can a biorefinery help the community, how can waste management help the community, I believe we can do a lot of value. We can build a lot of value and a lot of money with the materials that citizens are delivering to us. So we have to give back in some way. Lipor has dealt with it by building organic farming, urban farming plots for the citizens, completely free. We offer a compost bin to the citizens so they can do their composting at home. We also work with a lot of charity institutions where we can deliver to them with the money that we make with the waste. We can deliver to them some help with for those charities. So the waste management and the biorefineries and anaerobic digestion, it's a good bet for the community, because the community will also take back from those gains.
Okay, thank you. I'm agree with you. Not all the models works for all the places.
Yes.
Yes. Okay, Jose Maria, please.
Yes, it's coming to my mind opportunities, for example, of co-processing biowaste from municipal solid waste of great quality. With I'm thinking in regions in Spain, for example, and Southern Europe that has a lot of so horticultural crops. So it's very interesting for me, for example, because the amounts of horticultural crops are very big. So there is a big hundreds of thousands of tons of these residues, and then you can probably work together with the organic fraction on one side and with horticultural residues or at the same time, so you can enrich and give more scale and more feasibility to your projects. And also, speaking about the advantages, so it's clear that it's a big problem all over the world about the plastics. So plastics is at every scale. Is the use of safe plastic for wrapping the food. So we are still using plastic that migrate the plastic substances to the food in the drinks and the solid food also. And the other thing is the microplastics, for example. So I think all this circular economy and legislation and development of new projects of biorefineries. There is also in the plastic thing is a incredible potential of improving the environment and the health of the animals and the people.
Okay, thank you. It's interesting just to mix the different strengths, just to give more value to the biorefinery. Okay, thank you. And I have my last questions, but I think that was answered by you in the first question. That what are the main barriers to overcome for these bioproducts to enter into the market? And as you say, is the Jose Maria is the standardization, no, of the bioproducts and the legislation.
Yeah. Yes, but because in theory, you have the product, you can have the quality, but if you don't have the standard, the product is not standardized. So it's so you are out of the market. So and of course, I don't know Telmo opinion, but of course standardization works quite slowly because it's like a scientific thing, and they need to put to approve all the standards of the lab determination standards. So of course you cannot always make these things work faster. And with the standard thing, there is also a problem and an opportunity, because we are making new products. They are not standardized. They are not legally. There is not a legal frame for do it. But at the same time, these new products are competing with the traditional products. Let's say fertilizer, let's say plastics, let's say other products. And at the level of the committees, there is a problem, because you have a competition in the market, and you have a competition in the standardization committees, because the people that is regulating, the technician and the companies and the states that are regulating fertilizers, they are involved in regulating the traditional fertilizers, chemical fertilizers. And the people that are working in the plastic committee, they are people working in the plastic business. So there is a fight, a little question and a little competence, let's say, to how to regulate the bioproducts, because and it's a legal thing. It is also is a question of specific committees or evolution of the traditional committees working on traditional products to push for the bioproducts. So I have this feeling of there is a little bit of conflict with this thing.
Okay, but I think that it's the same from all bioproducts coming from every biomass, no? Jose Maria, I think that the problem is the same for all bioproducts, not only for the bioproducts coming from
of course, in general, can be made from vegetable product or from other origin, or for biochemical. Is of course, waste is also coming from waste, as unless you have the end of waste, is another barrier. But of course, is the new thing versus the old things conflict, I think.
Yeah. And for example,
I really have to agree with Jose Maria, because it's difficult. The regulation puts a lot of challenges for the implementation of bio-waste products, but I think that it's really necessary to have this legislation, and it's really necessary to have the standards so we can have quality products. I believe that the spirit of the regulation is to deliver to the market quality products, because as you all know, there's a lot of compost that comes from mixed waste. That you can identify the microplastics and the plastics directly just by watching it. So we have to control these materials. We have to help the market know what kind of material could be used in the soil, what kind of material can be used in the food production, because we can't use everything that comes from waste. And of course, there's a lot of pressure and a lot of lobby for the synthetic fertilizers, but I believe we can do the same. I think we should do the same. We should do lobby for the good things, and biorefineries and the bio-waste valorization. It's a good thing, so we should work with it, and we should try to implement this new products, the biostimulants, the biofertilizers, so we can show them that it's not just synthetic that works. The bio works better, even better than the synthetic.
Yes, I totally agree with you, Chelmo. It is necessary a standardization to assure the quality for the consumer. The point is that the legislation for the bioproducts, not only for biofertilizers or compost and so on, just for example, for biochemicals that are produced in the biorefineries. And it's a question just, for example, bioethylene or other bioproduct. If have the same quality of the ethylene, then we can give a difference between bioproducts and the fossil fuel bioproducts for a company that is consuming this building block. It's a question.
I'm sorry, I'm not sure if I understood. You're talking about the bioethylene?
We are speaking about biofertilizers, but the question is more focusing biochemicals, for example. If we obtain some biochemical from waste or from another biomass, that it's a bioproduct, for example, ethylene or bioethylene, if the ethylene have a standard, if the bioethylene commits the same standard, is valid for the market? Is my question, because we have a standard. It's just if the bioproducts can have the same standard that the current fossil fuel bioproducts, not bioproducts. What's your opinion about this?
Yeah, I believe
my opinion is we don't have a lawyer in the panel, so it's a question for a lawyer.
Yeah.
For a Brussels lawyer. Yeah. But well, I think in a way you are right. If you comply, we are producing in URBIOFIN, we are producing bioethylene, and it's I would say there is a clear possibility to make perfect bioethylene for the use. But of course, making bioethylene, and you are thinking also in bioethanol or other things, the reality, the projects are faster than the legal frame. So you are making a question to the, I would say probably yes, because we are seeing that we are using bio-waste fertilizers for organic farming. We are using bioplastics can be used also in organic farming. So I would say in the near future, of course, I think if you comply with the quality, you can use biofuel, or you can use bioethylene in agricultural production. But the question is, you are probably the first that is calling for that. You are going to the ministry to do this for the first time. So being the first is always a problem.
Okay.
For you, for example, as a pioneer.
Then we have to push in the project for this.
Yes. And mainly, I think my hope is also in the new projects, because of course we have a hard work in URBIOFIN to finish the project and to arrive to the results. But at the same time, you are thinking in new partners and new projects and new places to do things, because you learn and you are thinking the opportunities you can win with this learning.
Yes, but I think that in my opinion, it's just my opinion, we need to be more focused in not create new value, that of course is necessary, that in just apply the value, that the knowledge that we have with the municipal solid waste management plans, because if not, we have very nice projects, but these projects have to arrive to the market to be a reality. Then I think that we need to give more efforts just to contribute that the European Union money goes to the market and create jobs and create solution for these financial projects. Then this is my vision, okay, and my opinion, of course. Then I think that it's time to give the floor to the audience. My colleague Sara Castelló will be in charge of transmitting the questions of the attendees to the panelists. Then Sarah, please, can you have some questions?
Yes, we have a couple of questions. So the first one, Victor Perez from the University of Valladolid, he's willing asking Telmo if they are working on a specific product to be produced from biogas, either fulls or other bioproducts, and if he can provide information on the TRL of these technologies. Thank you.
Well, about the products, we don't have the anaerobic digestion, but we are designing it, and we are betting on the biomethanization of those materials. So this will be the main product of the anaerobic digestion. But we also have some sub products that could be used in a biorefinery, and that's what we are working together with BLC3, the technology center, that are helping us. But this is TRL 2, I believe. It's really just the beginning. We are not doing. We don't have any facilities of any biorefineries at Lipor. We are working at the lab level. Because my headphones got out of.
Yes, you.
Yeah.
Yeah, but that's just the beginning of a great road that we are walking with BLC3.
Okay, then you will be interested in the second part of the URBIOFIN project that it's using the anaerobic digestion platform to get bioproducts.
Yeah, I was really glad to see the agenda because it really mentioned everything that we are working with. So it tells us that we are on the right direction.
Thank you.
I believe we are.
That's very good. So I have a second question. I think it's also for you, Telmo. Jaime Cuevas is asking if you have checked about pollution or quality for local composting.
I'm sorry, the pollution from?
About pollution or quality for local composting.
Okay, yes, that's a problem we've been working with. There's a lot of information stating that the local composting may have a strong pollution factor if it is done wrong. So for many years I've been directly doing visits to the composting, to the local composting, and seeing how it works. And we don't have the numbers, but we don't know if when something goes bad on the composting, normally it's because of a lot of humidity, a lot of moisture in the compost, and that's when the problems come. That's when the bacteria start to produce a lot of strong chemicals, let's say, about it, chemicals that will pollute. But what I have seen in 10 years of composting at home in the Porto region, I can assure you that 90% of the people do the compost well. So you don't have a lot of pollutants coming from the local composting. I'm not saying it doesn't happen. I'm saying I believe it is a small fraction of the problem. That's not, I believe it's not the problem. Local composting is not that bad for the environment. It's really good for the environment because what we are doing with the compost is treating the bio-waste correctly. Okay, there's sometimes where things doesn't go as well as planned, but there's a small fraction. So we are doing some studies on it to try and understand what happens with the pollution from composting, from local composting. But we don't have many information right now. We just have the information that comes from the academia papers.
Okay, thank you. There are no more questions written, so if somebody else wants to ask, we can do it now, or just put your questions on the question section, and we will answer them in the second Q&A block. Thank you.
Okay, thank you, Jose Maria and Telmo, to participate in this first part of the workshop. And maybe at the end of the workshop, we'll have any other questions for you, and we can connect it again. Okay?
We'll be here. Thank you.
Thank you very much.
Thank you, Telmo. Thank you, Jose Maria.
Bye-bye.
Thank you for assisting. Okay. Now we are going to move to the second part of the workshop, that is more focused in the URBIOFIN project. We would like to explain the URBIOFIN project that is is a demo project, and it's a new urban biorefinery model that based in the basis that we were spoken this morning in the first part of the workshop. Please, can you move the next slide, please? Okay, as I said, URBIOFIN is a demo project, and we would like to demonstrate of an integration innovative biorefinery for the transformation of biowaste in bio-based products. It's not a radical change of the model of municipal solid waste management. We would like to introduce new concepts, new modules to transform the current municipal solid waste treatment plants in a biorefinery to obtain multiple bioproducts with higher value that give more value to the municipal solid waste treatment that now are costly inefficient for the citizens and for the local administrations. As I said before, this project was funded by the BBI and the European Union with 10 million euros just to demonstrate the viability of a urban biorefinery. Next slide, please. Okay, then the project objective is just to treat 10 tons per day of bio-waste in a modular biorefinery to obtain different bioproducts, building blocks like bioethanol, volatile fatty acids, and biogas that are going to be consumed in the same biorefinery to obtain different bioproducts as bioplastics, biopolymers, PHA, and of medium and short chain that are going to be used for cosmetic and agriculture uses, and additives as bioethylene that is going to be used for gas repairing, and biochemical products that biofertilizers, biostimulants, with the aim just to obtain a complete management of the waste and start all the value from this bio-waste in different bioproducts. Next slide, please. Then, as can you see here, this is the structure of the URBIOFIN biorefinery. Have 3 different modules interconnected with different flows. The first one is the biological and chemical module. The second one is anaerobic digestion platform, and the third one is a biogas platform, and is going to treat all the solid residues just to obtain biofertilizers. My colleagues are going to explain each module in the following interventions. Then is just to say that have 3 demo sites. Please, can you move forward a little bit? 3 demo sites, all local in Spain. The Imecal biorefinery pilot plant that corresponds for the first module. The Urbacer Centro Alfonso Maillo in Zaragoza, in which are going the second and 3 module, and Clamber that is in Puerto Llano in Ciudad Real, that is going to participate in the second module. Next slide, please. Well, at this moment, we are in the we have two and a half years of the project, and during these years we work extensively in the organic fraction municipal solid waste study at the European level. It's very important to know which types of wastes we have and how they are going to move forward and increase the quality in the next year, just to adapt our URBIOFIN model to the organic waste that we have today and that we will have in the near future. We defined the biorefinery process integrated in the 3 modules. And the logistics, just to treat all the waste. And of course, we built up and adapt the demo plants to treat these 10 tons per day of municipal solid waste. This is a big effort just to arrive until now. We started the demonstration process, but due to the COVID crisis, we had to stop during some months because we have health risks. But we are going to start the demo plants again in the following month, and we are going to start. At this moment we have good lab results, and we are going to start to have the demo and more real results, just to study the viability and the adaptability of the URBIOFIN plant to the current municipal solid waste treatment plants. Next slide, please. Okay, I would like to introduce the people that is working in the URBIOFIN project. This is is not the whole team is not here in this picture, but we have a great team working on it, and you can advance of 16 entities of all Europe. Can you move a little bit? Okay, this is the entities that are working in the URBIOFIN project. Different entities with different technologies from that cover all the value chain, from the municipal solid waste management operators, from the end of technological partners, of course, and of products testing companies that are included in all the URBIOFIN value chains. And now I would like to give the floor to my colleague, Dr. Marcos Latorre. Marcos Latorre is project manager at IMECAL SL. Has more than 10 years of experience in new materials and process development at laboratory and pilot scale plants and advanced characterization of renewable energy systems. Marcos, please.
Thank you, Caterina. So good morning. Well, at least in this part of the workshop, I'm going to describe. Sorry, you can see me now. Okay, sorry. So yeah, in this part of the workshop, I'm going to describe module 1 of URBIOFIN Biorefinery, which deals with the conversion of municipal biowaste into 2 bioproducts with a huge market, such as bioethanol and bioethanol. So if we move to the next slide. Next slide. Okay. So the goal of this module is to demonstrate at semi-industrial scale the techno-economic and environmental viability for the transformation of the second generation bioethanol produced from the organic fraction of municipal solid waste into bioethanol. Okay. Here we can see the value chain of the module, where the municipal biowaste is firstly converted into bioethanol through Perseo technology of chemical, and then this product is catalytically dehydrated this process into bioethanol. So this chemical has many applications in the market, and in this project it will be validated as ripening gas in fruit chambers. Okay. On the other hand, the bioresidue generated in module 1, in this module, will be further valorized by means of anaerobic digestion in module 2 of the urban biorefinery. Next slide, please. So, as I said, the first technology used in this part of the project is Perseo bioethanol technology. Perseo is a patented biotechnological process by IMICAL and thermal partners that converts the organic fraction of municipal waste and other waste biomasses into advanced fuels, bioproducts, and bioenergy. So the process has been developed since 2007 in collaboration with different universities, research centers, and private companies, and with the support of public authorities and municipalities. Perseo demo plant is located in chemical facilities in Alcudia, Spain, and it has a capacity to process up to 25 tons of organic waste per day. Next slide, please. So in this figure, we can see the general scheme of Perseo process. So the feedstock, which can be either municipal biowaste, such as URBIOFIN, but also other organic residues, such as agri-food, lignocellulosic, or paper and cardboard. Then this feedstock is treated to produce two main streams, which are the bioethanol and a solid bioresidue. Bioethanol is the most used biofuel worldwide, but also in the last years, its demand as a green chemical platform has significantly increased. So the Perseo residue is an organic material with a high calorific value, which can be further valorized to produce bioenergy through incineration or bio-based fertilizers by composting, or biogas by means of anaerobic digestion. So if we move, we can see that in URBIOFIN project, the bioethanol is used as a chemical building block to produce the bioethylene, and the residue is valorized by digestion to produce biopolymers from the generated biogas, as it will be shown by my colleague in next presentation. So next slide, please. So here we can see some pictures of Perseo semi-industrial plant in operation, where the organic municipal waste is pre-treated to eliminate most of the inert materials, such as plastics, glass, stones, and textiles, which are contained on it. And then the carbohydrates contained in the organic fraction are hydrolyzed to produce sugars, which are then fermented into bioethanol that is finally purified until the azeotropic point by means of distillation. At this moment, if this move to next animation. Yeah, so at this moment, the bioethylene demonstration unit is being constructed, and it will be installed in Perseo plant by next October. And in this unit, the advanced ethanol previously produced from municipal waste will be pressurized, evaporated, and catalytically converted into ethylene with a high purity. And this ethylene will be industrially validated for degreening different fruits in ripening chambers. Next slide, please. So, as I said, the two bioproducts produced in this module of the project have a large global markets, with the advantage that in this case they are not produced from edible biomass crops, but from waste biomass, which makes them much more attractive to the chemical industry. So in the case of bioethanol, the global market is expected to almost double until $65 billion in the next 5 years, while in Europe it is predicted to grow from 3 billion in 2013 to 13 billion in 2030. So this increase of the demand for bioethanol can be attributed to the mandatory use of bioethanol fuel blends in many countries in order to reduce the greenhouse gas emissions and increase the fuel efficiency of vehicles. However, apart from biofuel, ethanol is also considered as one of the top bio-based chemical building blocks for the chemical industry. And thus, for example, besides ethylene, ethanol has also been used as a chemical platform to produce other compounds such as acetaldehyde, propylene, ethylene oxide, or glutathione. Next slide, please. And in the case of ethylene, this is the most commercially produced organic compound in the world, with 140 million tons every year. And it is mainly used as a monomer to manufacture plastics such as polyethylene, PVC, polyester, or vinyl acetate. The global market size of ethylene is around $150 billion and is predicted to grow also at a compound annual growth rate of almost 10% in the next 5 years. So the increasing demand for sustainable chemicals will make that the bioethanol produced from bioethanol will make a more attractive product for the chemical industry as compared to its fossil counterpart. Next slide. So yeah, in conclusion, why producing added value products from municipal biowaste? Well, this option brings clear advantages in new waste management. Firstly, because these technologies are compatible with current municipal solid waste treatment models. They can be integrated upstream in current waste treatment plants, and once the value products are obtained, the residual organic streams can be treated with current processes such as composting or anaerobic digestion. So the sale of these bioproducts provide higher incomes to the plant, improving the economic balance. Also, this model is totally aligned with the new circular economy action plan of the European Commission within Europe's agenda for sustainable growth. And also, the model contributes to the reduction of greenhouse gas emissions from municipal waste management. And of course, it can increase the biodegradable municipal waste recycling rate, which is in line with the new more strict waste framework and landfill directives. And that's all from my side. So thank you for your attention, and I will be happy to answer your questions in the Q&A session later. Thanks.
Thank you, Marcos, for explaining perfectly the first module of the URBIOFIN project and the interconnection with the second module, the second module that is going to explain Juan Carlos. It's just to say that in the URBIOFIN project, we extract firstly one part of the carbon content, obtaining bioethanol just to produce bioethylene, and part of the residue of the first module goes to the second module with a new fresh material. And Dr. Juan Carlos Lopez, project manager at INEA Technological Center, that has more than 6 years of experience in anaerobic digestion-based biorefineries, with a special focus on biological gas treatment and valorization of high added value products, is going to explain the second module of the URBIOFIN project. Juan Carlos, please.
Okay, thank you, Caterina. Good morning, everybody. So let's move now to module 2, which is based on the combination of anaerobic digestion technologies with other fermentation ones in order to generate different types of biopolymers with different applications and characteristics. So basically, we are dealing with anaerobic digestion technology, which is a well-established technology. Indeed, we have already around 18,000 plants in Europe, and this is growing even faster. This is a waste stabilization technology traditionally used for the production from different feedstocks of bioenergy in the form of biogas that could be either used in a CHP unit for generation of power and heat, or that could be upgraded to obtain a biomethane that could be used as biofuel. On the other hand, also we produce, as you can see on the right side, digestate that could be close this traditional circular scheme and avoid the disposal in landfills. But we have to take into account the anaerobic digestion technologies up to date create low value from the operation, so as in the form of electricity and compost. And also when we are dealing specifically with municipal solid waste, we also have to deal with high landfill disposal costs. So next slide, please. We have to look for strategies to circumvent the volatility of market and price indexes of fossil fuels, and at the same time identify and explore alternative paths to create value apart from bioenergy and digestate within a biorefinery approach, since it has been estimated that up to 1,000 euros per ton of organic waste can be obtained. So the idea in URBIOFIN project has been centered in a chemical platform based on BFAs, as we will see now. Next slide, please. The technology we propose here in URBIOFIN project for Demo 2, and with the involvement of different partners such as BOR, Urbaser, Clamber, and INEA, is the separation, the physical separation of anaerobic digestion in 2 different digesters. So as we have the first one where we are going to produce these BFAs, which are chemical building blocks with an increasing market demand. These are acetic, propionic, butyric, and to a lesser extent valeric acids. And this is going to be produced under controlled operational conditions in order to obtain later a digestate that could be separated into a solid and liquid fraction. The solid fraction is going to be used for biogas and digestate production as in the traditional module. And on the other hand, we are going to have this liquid fraction enriched with BFAs that could be, on the one hand, could be subjected to concentration and purification if we are aiming at these acids with a high purity. But as it is energy demand process, and sometimes it is not cost efficient, the most interesting thing could be, considering the wide range of applications, to use it as valuable raw material for more valuable products. Next slide, please. So the idea we are dealing with in URBIOFIN project is to use these BFAs not for the downstreaming process, but to the creation of additional value through the formation of PHA, polyhydroxyalkanoates, in the form of short chain length or medium chain length PHAs, whose prices range from 2 to 10,000 euros per ton, and that have more interesting and demanded among the market. So they have outstanding mechanical and thermal properties. They are biocompatible and environmentally friendly, and also they are biodegradable in different environments, such as oceans, in the own anaerobic digestion technology, or even in soils, among others. Next slide, please. The first type of polyhydroxyalkanoates are the short chain length ones, and they are going to be produced in URBIOFIN with mixed cultures under aerobic dynamic feeding. As you can see in the scheme, we are going to propose two different tanks, the enrichment and the accumulation ones, in order to, in the first one, acclimatate or select those microorganisms with the ability to accumulate the SCL-PHA. And on the other hand, in the accumulation reactor, we are going to limit the nutrient, a specific nutrient, in order to promote the accumulation. The selection in the first one of the cultures is based on the sequential use of cycles of feast and famine regimes, so as the depletion in the second stage of the carbon source is going to select those microorganisms with the specific ability to accumulate these biopolymers. The rest are going to be dead. So these cycles are repeating once again and once again till we have a community with those abilities. After the accumulation reactor, we would have a biomass with high richness in PHA. This could be extracted, and through injection, we would construct these cosmetic pots we are aiming at. Next slide, please. In the second part of this scheme, we are considering MCL-PHA production with pure cultures and with elongation abilities. So basically, we are using a pure strain with the ability to produce these biopolymers. And this is going to be inoculated and cultivated directly in the so-called accumulation reactor. We are using this BFA-rich solution with water and nutrients, and we are going to use an alternative carbon source also to promote the elongation of the change of these biopolyesters to the medium chain length expected. At the end of the process, we are going to have this biomass enriched with PHA, and this is going to be extracted, subjected to blending, and with the appropriate additives are going to give us agricultural films and plastic bags. Next slide, please. So basically, these are the technologies that are conforming the module 2 in the URBIOFIN project. Dealing with two-stage anaerobic digestion system leading to these building block BFAs and leading to MCL and SCL-PHA production for different applications. Next slide, please. And as you can see in the last slide, we are moving towards from the traditional circular principle we see on the left, based on the production of bioenergy and biofertilizers from the traditional anaerobic digestion. We are moving towards a new model based on a two-phase anaerobic digestion system, where we are going to form these BFAs that could be used directly to produce SCL-PHA, or could be also sent to an elongation process to MCL-PHA production. And these both PHAs could be used for different packaging and agricultural purposes and complete the cycle. Next slide, please. So that could be all from my side. And I'd like to thank to the consortium for the opportunity to give this speech, and also to all of you for the attention.
Thank you, Juan Carlos, to explain the work that are doing the second module partners in the URBIOFIN project. And now we can move to the third module of the project that, as in the first module, use the biogas that is produced in the second module, and all the solid parts of the other modules, just to valorize them in this final module. I would like to introduce Víctor Pérez from the University of Valladolid. She's a project manager at this university, and her research focus on developing alternative biogas valorization strategies for producing biomethane and PHA in urban biorefineries. Víctor, please.
Well, hello, good morning to all. Thank you very much, Caterina, for the presentation. As you mentioned, I'm. Can you go back, please, or can I do it myself? Yeah, I'm Víctor Pérez, a PhD student in the Institute of Sustainable Processes from the University of Valladolid. My research is focused well on the URBIOFIN project and on finding alternative biogas valorization strategies to the traditional use of biogas for producing energy. Up to now, the anaerobic digestion has been a huge success, especially on reducing the amount of waste or organic waste sent to landfill. This has worked very well, especially because of the right valorization of the. Go back, please. I don't know if I'm doing this or yeah. And the anaerobic digestion has been a success because we have been able to use their main byproducts to add some value. For example, the nutrients present in the lixiviate, which is the solid fraction. We have been using them as fertilizer, and also the biogas, which is the gas phase coming out of the anaerobic digestion. We have been using it for producing energy and heat. This technology is especially relevant for European countries, as we have more than 18,000 operational plants in the moment, and this, as we can see from the graphs, this evolution or this creation of new plants has been associated to its capacity to generate electricity. Next slide, please. However, this model of using biogas to produce energy is a little bit compromised due to different factors. The first of them is that we're moving from linear waste treatment plants, in which waste is coming in and waste is coming out, to more circular biorefineries, in which waste is coming in and we want bioproducts to come out. This is one of the reasons, and also that other options for renewable energies have been developing much faster, especially solar and wind options, which are reducing the production cost very rapidly. And somehow biogas to energy technology has been left behind. Within the URBIOFIN project, we did an estimation of how these biogas to energy plants, regarding the economic of these plants in different regions of the world. And what we observed was that basically this technology is very dependent on the market, on the energy market prices. We can see that in countries with low energy prices, they wouldn't really be interested on this technology, as it is always cheaper to buy the electricity or the energy than to produce it yourself. On the other side, countries with higher energy costs are still interested, and the investment is a really good option, because it is always, as the prices of energy are very high, you can always go to the market and sell your energy and get benefit. which is especially relevant for us, is that, as we can see here, the regions, the European regions evaluated, are in a situation of a compromise where the economic feasibility of this plant is really dependent on the implementation of fiscal incentives. And if energy prices continues to go down as they are, it will be soon no longer an economically viable option. Next slide, please. So then the idea is, okay, we have waste treatment plants, we are producing a lot of biogas, but it is not a very good idea to produce energy out of them. So what do we do with this biogas? Okay, we are especially focused in this project on finding alternative biogas valorization strategies, especially biological technologies for producing all sorts of bioproducts. I will explain in little detail the two of them. Next slide, please. So, okay, the first technology that we will demonstrate in the URBIOFIN project is based on the action of microalgae and bacteria. And the main idea is that we're converting the two, let's say, low added value byproducts of the anaerobic digestion, which are biogas and digestate. We will convert them into high added value byproducts, such as biomethane and microalgae-based fertilizer. Basically, biogas is around 50–60% of methane, and it carries a lot of other pollutants that we don't want in our fuel. With this technology, we can obtain a biomethane with around 95% of methane, which is a comparable product to natural gas. And we can either inject it into the natural gas grid or just use it as a fuel in vehicles. All the microalgae and bacteria that will grow in this photobioreactor can be harvested. We can do a hydrolysis reaction, and we're obtaining a microalgae-based fertilizer very rich in amino acids. And next, please. Okay, regarding the biomethane market, we can observe that whether anaerobic digestion plants and the installed electric capacity is slowly slowing down. It's not growing as fast as the biomethane plants, which give us the idea that this market is growing very rapidly. There are a lot of platform technologies for transforming or for cleaning this biogas into biomethane, but we believe that microalgae-based technologies have a clear advantage because of their minimum energy consumption and also the reduced environmental impacts. Next, please. Here it is basically what we will do, what we will demonstrate in the URBIOFIN project. It is a pity that I cannot show you any videos or pictures of the pilot plant working, because it is actually being assembled during this week. At the left, we can see the photobioreactor of almost 300 square meters that we have constructed in Urbaser facilities in Zaragoza in the waste treatment plant. And we are aiming at producing around 8 cubic meters per day of biomethane. We will have to control the quality of this biomethane during the whole year, as this technology is really dependent on climate conditions. And on the other side, we will be producing around 3 to 4 kilograms per day of microalgal biomass that we will send to INEA, another partner of the project. They will run the enzymatic hydrolysis for obtaining the protein and the amino acid content out of microalgae. And finally, Biomasa Peninsular will formulate and will run agricultural field tests with the resulting product. Next, please. Now, this is the second technology in which we are working. It is a completely different technology from the previous one. In the previous one, basically, we wanted to remove everything that was not methane from the biogas. In this case, we want to do exactly the opposite, to remove the methane. First, we are going to do this in a two-stage system. In the first stage, we are removing the hydrogen sulfide from the biogas, which is highly corrosive and toxic, and we don't want it in our gas stream. And in the second bioreactor, we have a culture of methanotrophic bacteria. These bacteria have the ability to, let's say, eat the methane, they consume the methane, and under certain conditions, they are able to accumulate polyhydroxyalkanoates inside the cells. These polyhydroxyalkanoates, as Juan Carlos explained before, is a really interesting biodegradable polymer, which is gaining a lot of attention from the industry. And next slide, please. The previous one, yeah, that one. So, okay, we know that this technology, turning methane into biopolymers, is viable at laboratory scale. In the URBIOFIN project, we're going to test it in a demonstration scale, but we wanted to know, okay, how will this look if we do it in a real industrial plant? So that's why we did this techno-economic analysis. The first question that we wanted to answer was, okay, what will happen if we take all the biogas that we're producing and instead of producing energy, we produce polyhydroxyalkanoate? Well, we observed that only for countries with low energy prices, the final production cost of PHA would be competitive in the market. This is in part interesting, as we saw in the previous slides. These countries would not be very motivated to use anaerobic digestion if they only can produce energy, but they might be motivated to improve the waste management if they can get a higher added value product from biogas. The second question is, okay, if we in Europe, we want to produce polyhydroxyalkanoates at a competitive price, what shall we do? Well, our proposal is that once that we already have a lot of anaerobic digestion plants, we are producing a lot of biogas, and we have the ability to transform this biogas into electricity, but this electricity, you cannot go into the market and sell it because it's very cheap and you're not getting a lot of benefit. Then why don't we use this energy that we're producing for our own process? In this way, basically, we can reduce drastically the prices, the production cost of PHA down to 4 euros per kilogram, which is in line with the current market price of polyhydroxyalkanoate. So the idea would be, instead of selling the energy, use it for producing biopolymers. Next, please. Next slide, please. Okay, so so now we know that we have a viable solution for using our biogas, that we can produce a high quality product at competitive market prices, but we should check this from the point of view of sustainability also. From the environmental point of view, there are two main aspects which makes biopolymer production from biogas a better option than energy production. The first is that we are avoiding the emission of a lot of methane and carbon dioxide emissions. And the second one is that we will be able to close the cycle on plastics. Once we have the polymer, we use it, it can go back to the anaerobic digestion stage, it will degrade, produce more methane, biogas, and again, biopolymers can be produced. And from the societal point of view, this is similar to what Telmo mentioned. It is not very easy to put into numbers how will society benefit from future urban biorefineries. There are several aspects that we consider. The first one is that the emission of odors will be reduced, then neighboring community will be very happy. And also that urban biorefineries might have associated a job creation in the region more than producing energy. And also it will somehow respond to the growing consumer demand for bioproducts. Next slide, please. Just a stay-home message. Well, basically, we have to take in mind that the model that we have used for these many years was very good, but at some point it might be compromised by the energy markets and commodity prices and external aspects. So we have to find new solutions for using this biogas and to provide bioproducts. Especially, we have been focused on one, producing biofuels that are already in the market using microalgae. And we think that this technology is very competitive against physical chemical technologies that are doing the same thing. And for the biopolymer production, apart from being able to produce a competitive product, it has associated also positive environmental and social impacts. Next. And thank you very much.
Thank you, Victor, for explaining so well the third module of the URBIOFIN biorefinery. We are on time. Then we have just 10 minutes for questions and answers. I would like to invite all the panelists to open the camera just to participate in these questions and answers round. And Sarah, please, if you can transmitting the question and answers of the attendees.
Yes. So the first question goes to Marcos. So what is expected yield of ethanol per ton organic matter in feedstock? And also along this question, what yield is required to have a feasible operation?
Yes. Well, of course, the yield depends on the feedstock that we use. Typically, we are for this project we are speaking about municipal solid waste, the organic fraction of municipal solid waste. Typical yields are around 70 liters of ethanol per ton of waste, which is around 140 liters of ethanol per dry ton. This is the typical value that we obtain in our semi-industrial plant, and this is a value which makes the process feasible. The process is feasible and viable from the technical and.
Mm-hmm. Okay, thank you. So second question goes to Juan Carlos. Well, we have a couple of questions. So first one, how is digestate separated in solid and liquid?
So this separation could be made by different methods. We are exploring now which one would be more cost effective, and we are considering polyelectrolyte separation.
Okay. And second question, what is expected PHA concentration in PHA-rich biomass?
So the contents, as Marcos mentioned before, the contents depend on the solution of BFAs that we are going to feed to the system. So depending on the contents of acetic, butyric, propionic, and valeric acid mainly. And the contents can range from 20 to 40, 45%, depending on that.
Thank you. We have a question for Victor. So, which is, what are the benefits of your route to produce PHA from biogas instead of the BFAs as shown by Juan?
Okay, that's a very good question. I'll try not to be partial. Maybe Juan Carlos can answer after me. Well, there are several things to have in mind. I would say that, for example, the BFA route is a simpler technology, as it is very similar to typical fermentation technologies in which the substrate is already in the liquid phase. But, for example, but it also, let's say that you have to change your anaerobic digestion system. Maybe it is more difficult to implement it in a currently constructed plant, as you have to run the anaerobic digestion in two phases for the if you use biogas, first you have a substrate with a constant concentration, because it is not changing a lot, and you can already implement it in an anaerobic digestion system. You just have to change the flow of your biogas from producing energy to producing another thing. I don't know if Juan Carlos wants to add something on that.
Yeah, I think you have summarized all the differences between both technologies. Also, it is important to take into account that BFA's concentration must be properly controlled. Biogas cannot inhibit. I mean, the concentration of methane is not going to inhibit your culture, but BFAs could inhibit if you not control your concentration. So this is going to limit also the productivities with BFAs compared to the use of methane, for sure.
But this is definitely something we will know for sure at the end of URBIOFIN project.
For sure.
Yes. In the next chapter of.
Thank you for both for the Sorry.
Yeah, I think both options have advantages and disadvantages, and depending on, as Victor explained before, depending on the scheme of the anaerobic digestion plant, one or the other would be the option to choose, I guess.
Okay, next question then. This is in general for all. Do you include green waste from running gardens, parks and cities as feedstock in any of the projects you presented this morning? This goes to Caterina.
Sorry, can you repeat, Sarah?
Yes, sorry. Do you include green waste from pruning, from gardens, parks in cities as feedstock in any of the projects were presented in the morning?
Yes, not in your URBIOFIN project because it's more focused in urban waste, but in other projects, as for example Waste Hub projects and other projects, we have different pilot plans that include this kind of wastes. The idea is just to treat, have versatility in the biorefineries to treat each waste in different way, just to maximize the value that we can extract from them. Then, of course, the waste garden have to treat in different way that the organic waste, because it have the different compositional structure.
Okay, thank you. Another question for Victor. So, question for demo 3, yes. Which is the estimated production of PHA from biogas?
Well, the study that we did was based on a, let's say, medium-sized plant, which is around 1,000 cubic meters of biogas per hour, and that would result in a yearly production of a few hundreds of tons of PHA, ranging from 300 tons per year to 800 tons per year, depending on whether you're using some of the biogas to produce energy or not. I think the number is like 0.1 kilograms of PHA per kilogram of biogas.
Okay, thank you. Next question. This is in general for URBIOFIN. Consumer acceptance or perception of obtained products is analyzed in the project.
Yes, of course. This is an important point of the project. In some work packets, we work on legislation and of course of the consumer acceptance. For this reason, the application of these bioproducts are not in food and pharma markets, are more focused in agricultural markets, just to and in cosmetics too, but mainly in agricultural because it has more acceptance in this sector, the bioproducts that came from waste. But I think that in the first part of the workshop, we're speaking that it's important just to change the legislation, and of course to do campaigns to the people and to obtain a good standardization, just to assure that the product is the same if it's coming from waste or if it's coming from another biomass.
Mm-hmm. Many thanks, Katerina. Now a question for Marcos. How advanced is the first module to reach the market or to be near of commercialization?
Pardon, can you repeat, Sarah?
Yeah, how advanced or in which stage is the first module in order to go to reach the market or to go to commercialization?
It is very near to market. Okay, so the bioethanol production is very advanced. Okay, and as I said, the yields that are obtained are the ones that are feasible, but of course we want to give more value in URBIOFIN project. We want to give more value and use this ethanol not only used as a biofuel, but also as a chemical building block to produce even a higher value products, and also valorize the bio residue that is coming from the process. There are different options to valorize this bioresidue, and in URBIOFIN we also trying to giving more value to the bioresidue, but it can valorize with current technologies such as anaerobic digestion or composting, or it can be even incinerated.
Yes. If I can add something, the module 1, the Preseo process, is complete, ready to go to the market. In other projects, for example, Waste to Bio, that is more focused to use bioethanol for biofuel production, is completely developed, and we use the other flow, the residue, just for anaerobic digestion and biogas production. And this is completely developed, and we are doing quotation to the market with this module. And as Marcos said, in URBIOFIN we are more focused for bioethanol as a chemical building block. This is which are testing in the project. Mm-hmm.
Okay, thank you. And also last question for Marcos or Katerina. Is there a difference in terms of investment to produce chemical building blocks or biofuel from ethanol?
Marcos, if you want.
Yeah, I mean,
sorry.
The main difference lies in the last step in the purification, because for using as a biofuel, you require a lower requirements, and when you use as a building block, there are different some other requirements. Okay, so it depends on each of application, but typically there is not so much difference. It's just some other steps of purification of the ethanol when you use it as a chemical platform than when you use it as a biofilm. It's just a minor difference in the purification step, in the distillation.
Okay, thanks a lot. We don't have any more questions, but if you want to add any comments or yeah, so now it's the time.
Okay. I think that Sarah, we are on time. We are just arrived to the end of the. If you have more questions, please send us, and we try to answer the questions as soon as possible. And I would like to thank the participation of all the panelists, the efforts to be today in this situation here online, and of course to the all assistants just for the interest in the project. And you can follow us by Twitter, LinkedIn, and so on. We publish the news and the results of the project, and the idea is to organize a new workshop when we finish or we have more advanced the project. Showing the results of the project, and of course inviting other similar projects to share with us the experience. And that's all from our side. Thank you for the assistance.
Thank you to all. Thank you very much.
Thank you.
Thank you.
Thanks.
Have a nice day.
Thank
Bye
you.
bye.
Have a nice day. Bye.
Bye bye.
Bye.